I'm just going to pick up right where we left off in the last video. So we had put the positive degrees on here going around the unit circle counterclockwise, positive degrees that went with the 60-degree dots. So we need to go back around the unit circle clockwise and do the negative ones. Okay, so if I go down from the x-axis, I'm heading this way to get to that green dot. That's going to be negative 60. Right, remember it's the same distance as this one, just in the opposite direction. All right, continuing on around to here, that's 60 degrees away from that negative 180. So I've got negative 120. Going 60 degrees past negative 180, negative 240. And then continuing on around till I'm almost at 360, negative 360. That's going to be negative 300. Okay, let's go back and do that in radians. So when I move this way, I'm doing positive radians. 60 degrees times pi over 180. 60 goes into 180 3 times. So this is going to be pi over 3. Continuing on around the unit circle in a counterclockwise direction. Remember, this would be 3 pi over 3. And I have to move backwards 1 pi over 3 from that. So that's 2 pi over 3. And you remember our pattern, the numerator is 1 less than the denominator. Coming this way, the numerator is going to be 1 more than the denominator because I went 1 pi over 3 past 180. So now I'm going to be at 4 pi over 3. And then right here, 2 pi, that would be 6 pi over 3. And I didn't quite make it. So 6 minus 1 is 5. 5 pi over 3. Okay, now let's go in a clockwise direction. Let's do those negative angles. Okay, and remember, basically we're just flip-flopping these and changing the sign. So when I come this way, I have gone negative pi over 3 radians. Continuing on around here, I'm 1 pi over 3 away from negative 3 pi over 3. So that puts me at negative 2 pi over 3. All right, moving on in this direction, I go an additional pi over 3 from negative 3 pi over 3. That puts me at negative 4 pi over 3. And then right here, I'm pi over 3 away from 2 pi. 2 pi is 6 pi over 3. 1 pi away from that, negative 5 pi over 3. Okay, so there's all my green angles. Pause the video. Make sure you've got the positive and negative degrees and the positive and negative radians. All right, the last ones we need to look at are these black ones. So take your last colored pencil, and you don't even have to use your protractor on this one. You're going to put the points where the unit circle intersects the X and the Y axis. And then put your parentheses outside of there just like we've done so that we can fill those in during class. Okay, so let's see what degrees and radians we have. Let's go in a positive direction. Starting here, well, if I start at the x-axis and I'm on the x-axis, I haven't moved at all. So that would be 0 degrees. And then basically, if you think about it, we split the circle up into 4 quadrants. Each quadrant is equal, so 360 divided by 4 is 90. So this is going to be 90 degrees. 90 more over here is 180. We've already talked about that one a lot. 90 more is going to put us down here at 270. And that last 90 put us back over here at 360. And we've talked about the ones on the x-axis. We just really haven't talked about the ones on the y-axis very much. Okay, let's go the opposite direction. Let's do the negative degrees. Well, I don't need to write anything for 0 because 0 is not positive or negative. So I'll go this way, 90 degrees. That puts me at negative 90. We talked about this one already, negative 180. Continuing on around the circle, continuing on around the circle over there, we're going to get negative 270. And then finishing up down here back where we started at negative 360. Okay, let's do those angles in radians. All right, well, 0 times anything is 0, so 0 degrees is also going to go with 0 radians. The only difference, look, this one has units, 0 degrees, and radians, no units, just 0 for 0 radians. All right, coming around over here, we've got 90. If I change degrees to radians, I multiply by pi over 180. 90 times pi over 180. 90 goes into 180 two times. So I've got pi over 2. And every time I go all the way a quarter of the way around, I'm going to get an additional pi over 2. So pi over 2 plus pi over 2, 2 pi over 2, which is pi. All right, so 2 pi over 2 and an additional pi over 2, that's 3 pi over 2. And 3 pi over 2 and one more pi over 2, that's 4 pi over 2, which is 2 pi. All right, and then if we go the opposite way, let's do those negative radians going this way. So I'm going to have negative pi over 2. I'm going to go another negative pi over 2 to get here, so that's negative pi. Another negative pi over 2 to get here, so that's negative 3 pi over 2. And then I'm going to finish up over here at negative 2 pi. So this one's a little bit crowded because it has all kind of angle measures on there. All right, pause the video, get all your black ones written. Okay, I do not want you to draw this triangle inside your unit circle. You probably don't have any space left inside of there anyway. And what we're going to do is we are going to look at what happens to the signs, SIGN, of the trig functions when we're in each different quadrant. So we're going to look at the first quadrant first. All right, if I look at cosine of theta, cosine is adjacent over hypotenuse. So you can see automatically that cosine is going to go with the x-axis because cosine is adjacent over hypotenuse. And if I look at the x-axis in this quadrant, it's going to be positive, right? Because I'm on the positive part of the x-axis. So cosine in the first quadrant is going to be positive. All right, let's look at theta again. Let's do sine. Sine is opposite over hypotenuse. Well, the hypotenuse is the 1, right? Because it's the unit circle and the radius is always 1. So opposite over hypotenuse. Well, this value goes with the y-axis. Sine, you can tell, is going to go with the y-axis. They're parallel to each other there. And the y-axis is positive. So therefore, this is going to be positive. So sine is also positive. Now, tangent is opposite over adjacent. Well, this side was positive and this side was positive. So therefore, both of them are positive. So what I want you to write in this quadrant is that all of them are positive, and underline that A. We're going to come back to that in a minute. But they're in the first quadrant, all of them are positive. And you'll write that outside of your parentheses. I had to erase the parentheses because I don't have enough space. Okay, let's move over into the second quadrant. So here in the second quadrant, going back to my angle theta, cosine adjacent over hypotenuse. Adjacent in this case is going to be negative. You can see I'm on the negative part of the x-axis. So cosine is going to be negative. Sine, opposite over hypotenuse. Well, this is positive, just like the y-axis is positive. So sine is going to be positive. And tangent, opposite over adjacent. It's going to be positive over negative, which works out to be negative. So in this quadrant, sine is going to be positive, and underline the S right there. And if you think about it, what was the reciprocal of sine? The reciprocal of sine was cosecant. So if sine is positive, cosecant is also positive. Okay, so again, just write that outside of your parentheses. I just had to erase my parentheses so it would fit. All right, let's move down into the third quadrant. So you notice when I'm doing that, I'm always putting my angle theta as close to the origin as I can, and I'm always measuring from the x-axis. That's very important. You always measure from the horizontal axis. So theta cosine adjacent over hypotenuse, cosine going with that x-axis right there, adjacent over hypotenuse. Well, I can see that this part is going to be negative because I'm in the negative part of the x-axis. So cosine is going to be negative. Sine is opposite over hypotenuse. So opposite is here, and I can see that I'm negative, like the y-axis is negative down here. So sine will also be negative, sine going with y. Now let's do tangent. Tangent is opposite over adjacent. So tangent is negative divided by negative. Well, I remember that negative divided by negative is a positive. So in this third quadrant, tangent is negative. Underline that T. And if tangent is negative, then its reciprocal is also negative. So do you remember the reciprocal of tangent? Reciprocal of tangent is cotangent. So tangent and cotangent are both positive here in the third quadrant. All right, let's move over to the fourth quadrant. So in the fourth quadrant, cosine, going with x, cosine is adjacent over hypotenuse. So I'm back to x-axis being positive, so cosine is positive. All right, so I'll put cosine down here. All right, sine is opposite over hypotenuse. Well, I can see that this part of the y-axis is negative. I'm down here. So sine is going to be negative in the fourth quadrant. All right, how about tangent? Tangent is opposite over adjacent. It's the ratio of those two. So tangent is negative divided by positive, and negative divided by positive is negative. So therefore, tangent is negative. So the only thing that's positive in the fourth quadrant is cosine, and its reciprocal. The reciprocal of cosine was secant. Cosine and secant are both positive. Underline that C over there. Okay, now if you look at those letters, I have an A here, an S here, and I had a T here. A couple of different ways you can remember that. First of all, it spells out the word cats. If you start in the fourth quadrant, C-A-S-T, cast. Sorry, not cats, cast. C-A-S-T. All right, so that's one way you can remember which angles are going to be positive, or which trig functions of those angles are going to be positive, I should say. Another way, and this one is probably more common because it starts in the first quadrant, all students take calculus. Not a true statement. Lots of people don't take calculus, actually, but that big fat lie does help us remember all things are positive in the first quadrant. Sine and cosecant are positive in the second quadrant. Tangent and cotangent are positive in the third quadrant, and cosine and secant are positive in the fourth quadrant. So either cast, C-A-S-T, or our phrase, all students take calculus. Okay, so when we come into class, we're going to fill in all these point values, and you're going to see how this all students take calculus. You're going to see how that is important as we fill in the values for sine and cosine and tangent all the way around the unit circle.